Welcome. So what I want to do is show you how to divide rational fractions. When I'm dividing rational fractions, remember my theme of this whole video series is to simplify, simplify, simplify. Now, this is a problem we could easily go through this without actually doing simplifying our negative exponents. But I don't like dealing with negative exponents because I see a lot of students, including myself, will make mistakes with our negative numbers. So the first thing that I always like to do is get rid of our negative exponent. So I'm just going to kind of do this over here and to see, well, how, again, do I eliminate negative exponents? All right, so remember when we have a negative exponent in our numerator, to make it positive, we just need to put it in our denominator. And when we have a negative exponent in our denominator, to make it positive, we'll put it in our numerator. So therefore, the simplified version of this is going to be 6x to the fifth over 5y to the positive third. All right, so I'm just going to rewrite the problem now with positive exponents. And I like positive exponents because they're just a little bit easier for us to work with. Okay, so now we need to say, what do we do then with division? And division and multiplication, students like a lot better than adding and subtracting because we don't have to worry about common denominators. We're just going to be multiplying them across. However, we're not just going to multiply them across like multiplication, but remember division is the exact same operation as multiplying by its reciprocal. All right, so what I need to do now is I'm going to change this from a division problem. I'm going to change it to a multiplication problem, but I can't just multiply by the same numbers. I have to multiply by the reciprocal. So therefore, I'll rewrite this as 3x cubed over 5y squared multiplied by the reciprocal, which would be 5y cubed divided by 6x to the fifth. Now, as it's written as a multiplication problem, I can just multiply across. So 3 times 5 is going to equal 15. X cubed times y cubed, they don't have the same base, so I cannot combine them. 5 times 6 is going to be 30, and then y cubed, x to the fifth. I'm sorry, y squared. Okay, so now we have a couple of things we need to do. We have 15 over 30. We need to see how can 15 over 30 be reduced? Well, 30 doesn't divide into 5, so we know we're going to be left with the fraction. Well, 15 over 30, that reduces down to 1/2. And then remember, I'll just kind of work through this for these couple problems. Remember, when we have bases with the fractions, we subtract the fractions. So this is going to be x cubed minus 5, and then y cubed minus 2. All right? So therefore, that equals 1/2 x to the negative second and y to the positive first power. So when looking at this, and these are all in the numerator, what you see here is x to the negative second. So for me to make this positive, I need to put x squared, positive 2, in the denominator. And since this is positive, I can leave this in the numerator. So my final answer is going to be y over 2x squared. I didn't need to keep the 1 up here or the 1 as the exponent because it's not going to be altering my y in my numerator. But however, my 2 is in the denominator, and then I'm going to have to rewrite x to the negative second down in the denominator as well. So therefore, ladies and gentlemen, that is your final answer. Thanks.